So this little sign here, little e, means element of. This sign here means null set. There's nothing in the set. So A is a subset of B if for every x that's in A, it's in B. So that would look something like that. So this says that 1, 2, 3, sorry, the set 2 is a subset of the set 1, 2, 3. And this says 2 is an element of that set. So if it's not a subset, this would be a picture of A and B not being a subset because there is an X that's in A that's not in B, or this could be that they're not subsets. So it's a proper subset if A is contained in B like that. If there's something in B that's not in A. All right, let's go through these. So is 3 an element of this set? Yes. Is 11 a subset of this set that contains 11? No, 11 is not a set. Is 11 an element of the set that contains the set of the number 11? Yes. Is the set 11 a subset of the set 11 that contains the number 11? Yes. Is the set 4 an element of the set that contains 3, 4? No. Is the set 2 an element of this set that contains this? 1, set 2, set 3. Yes, it is. So this is an element inside. Is this set 1 a subset of the set that contains those 4 numbers? Yes. Is 1 an element of the set that contains the number 1? Yes. Is the set 1 an element of the set that contains number 1? No. Is the set 1 a subset of the set that contains the number 1? So is the set 1 a subset of the set that contains the set 1? Yes. Is the set 1 an element of the set that contains the set 1? Yes. Oh, hold on. This one's not right. So the set 1, is that a subset of the set? No, that's right. Yes, that set that contains the set 1. Yes. Is the set 11 a subset of the set that contains 11? Yes. Is the number 0 in here? No. Is the null set an element of the set that contains the null set? Yes. Is the null set an element of the set that contains the null set? No. Is the null set an element of the null set? No. Phew. All right. So we're going to be doing this. We're going to be proving if A is equal to B, that A is a subset of B, B is a subset of A. So it goes both ways. All right. So they're mutually disjoint if anytime you take the intersection between two of them, you get the null set. So I can say a whole bunch of sets, A1, 2, 3. So but if this was A1, this was A2, and this was A3, they're mutually disjoint. They have nothing in common. And all of the A's joined together make the big set A. Union means it's in A or B. Intersect means it's in A and B. And this is kind of a new one, B minus A. It's in B, but it's not in A. So that's called the relative complement. And A complement means X is an element of A. All right, so let's go and draw some number lines so we can get this. So this A here is between -3 and 0. So anything in between there. So B is between 1 and 4, open space of the 4, and that's B. And then C is between 3, including that, and 9, not including that. Okay, so A intersects C, there is nothing in common, so that's the null set. So B complement, so we would say X is an element of the reals such that X's are smaller than 1 or X's are bigger than or equal to 4. So A union B, so taking this and this, so that would be X is an element of reals such that we've got -3 X 0, or, right, could be the other one too, or 1 X and 4. Okay, so A union B complement, so the opposite of this, or what is not in there. So this would be the x's are smaller than -3, or I've got between 0 and 1, or x's are bigger than or equal to 4. All right, does that turn out to be A complement union B complement? Let's check it out. So A complement, I'm just going to write it down here. Let me write it here. A complement. Let's write out A complement. So that would be, hold on a second. I think I'm going to run out of time. Let me start that on the next video.